Welcome back. In this, our third video on using and programming Arduinos, we will use pulse width modulation to dim an LED, and then use an input to create a light sensor. Let's jump straight into things and look at some code. This code has a lot of similarities to the program Blink. One difference is instead of saying LED equals 13, we're saying LED equals 9. This is because pin 9 has a tilde on it, and so can be used for pulse width modulation, something pin 13 can't be used for. This is exactly the same. We're defining pin 9 as an output, but down here, rather than saying digital write, we're saying analog write. And we're writing 255, which is the equivalent of high. This will set the brightness of the LED. The minimum value is 0, and the maximum is 255. Let's upload this to our board and see how it looks. Not the most exciting result, but then again, all we did was tell the Arduino to set the brightness to maximum. Let's modify this number here and see how things look. Here is the LED at brightness 255, 150, 75, 30, 10, and 0. So now you know how to use analog write to set the brightness of your LED. But what if we want to have something that changes over time, such as a pulsing light that gets brighter and dimmer? Well, the Arduino interface comes with an example sketch that does exactly that. Go to File, Examples, Basics, Fade. As it says up here in the notes, this example shows how to fade an LED on pin 9. Scrolling down, we can see that it starts the same as ours, with defining LED as 9, but then there's two more variables. There's this brightness and fade amount. Down here in our loop section, you can see that we are analog writing the LED to be equal to brightness. Then, the value of brightness gets updated to being brightness plus the fade amount. But what about this bit down here? If brightness is less than or equal to 0, or brightness is greater than or equal to 255, fade amount equals negative fade amount? And why are we restricted in using values from 0 to 255 to define an output anyway? This has to do with the way that computers deal with numbers. Computers count in binary, that is, ones and zeros. An Arduino has an 8-bit processor. That means that there are 8 digits to any number that it considers. If these are all zeros, it's the lowest number it can have, 0. If they're all ones, it's the highest number it can understand, 255. Now, let's look at that last little bit of code. After a 30 millisecond delay, we loop back around and update the brightness of the LED. Let's upload the sketch to our board. Now, let's look at how we can use the Arduino's analog pins as an input, and then build a light meter. The Arduino interface has an example of an analog input. To open it, we're going to go up to File, Example, Basics, and go to Analog Read, and we're going to choose Analog Read Voltage. In this script, we begin with this part where it says serial begin 9600. This means the Arduino can transmit information back to the computer. Down here, we've got our loop, which says we're going to read a sensor value from pin A0. That number will be between 0 and 1023. To make that into a voltage ranging from 0 to 5 volts, we're going to take the sensor value and multiply it by 5 over 1023, which is the maximum value it can give. We're then going to say serial print voltage. This means it will communicate what that voltage is back to the computer and we'll be able to read it off. Let's now look at our circuit. This cable here takes 5 volts and puts it into our breadboard. That then travels through a photoresistor Here we have another cable connected to pin A0, which lets us do our read, and then a 1 kilo ohm resistor, which connects back to ground. Let's upload our sketch. Over on the board, we can see that the TX light is on. This is because it is transmitting information back to the computer. But where is that information? Well, to see it, we need to open the serial monitor. Here you can see a constant updating stream of information. Currently it's saying there's about 1.9 volts coming in through A0. If we were to shine a light on the resistor, you can see it jumps up. If we cover the resistor, it goes down further. This lets us convert the number that we see here into a representation of the amount of light. The higher the voltage that is being seen by A0, the more light is in the room. And this is information we're going to use to build our light level indicator. This is the script we're going to be using with our light meter. It isn't necessarily the best way to do it, however, it works. And when you're starting out, works is what you're aiming for. We begin by assigning 8 of our output pins to powering 8 LEDs, which I've labeled L1 through L8. Next, we're giving the value voltage 0. Here we say float rather than int. That's because a float has decimal points, and we want our reading to have decimal points associated with it. Next, we declare all of those LED pins as being outputs. Down here in the loop, this bit here about sensor value analog read A0 and voltage equals sensor value is exactly like we had in our previous script. Except, this time, we are not going to be opening the communications between the Arduino and the computer, because we're going to be using the LEDs to indicate the amount of light, not reading it off the serial monitor. To actually turn on the lights, we're using a series of if statements. This says if the voltage is less than or equal to 1, turn off all the LEDs. If the voltage is greater than 1 and less than or equal to 1.5, just turn on the first LED. This continues down until eventually we make the statement of if the voltage is greater than 4.5, we want all the LEDs on. Then wait 100 microseconds before going through and assessing the light level again. Let's now take a quick look at our breadboard before we power up our Arduino and look at our light meter in action. Here's the setup we'll be using. You'll notice that our photodiode setup is exactly the same as it was before. Now the only thing that's changed is we've got each of these pins along here from 5 through 12 connected to a 220 ohm resistor and then an LED. We can now plug in our unit and see what it does. You can see currently we've got 4 lights on. If we put some shade over our photoresistor, they start to turn down. We can have them turn off. If we get out the light, we can show that they increase as the intensity also increases. There you have it, an Arduino-based light level indicator. If you'd like to see how this could have been done using a shift register, or if there are any other projects you'd like to see tackled, please let me know about it down below. Until next time, stay creative.